Students. Today we're going to go over the creation of assembly drawings. So the assembly drawing has a number of functions. It's going to tell us where to locate each assembly component. It's going to tell us the part number of each of those items, and it's going to tell where each component can be purchased from, if it is a purchased part. So let's begin. The first thing we need to do, we're going to make sure that our properties are fully filled out. This will ensure that our title block fills properly. So we have the part number, that's good. The revision has a dash, and we have a description, which will become our drawing title. I'll say OK. The next thing we need to do is we need to create an exploded view. We're going to pull this apart so that we can describe to the assembler where each component goes in a convenient picture. So I'm going to rotate this around a little bit. I'm going to say Insert, Exploded View. I want to pull this nut down here to show the assembler that it goes in this direction. So I'm going to choose on the bottom flat face. That gives me this XYZ coordinate system. If I click on any one of the arrowheads, that will set the direction of my explosion. So I'd like Y so that I go up and down the shaft of the bolt. Pull it down to here. I'm going to say OK. The next thing we need to do is put in some explosion trace lines. That's going to show where the component goes. It's not super important in this simple example, but when you get many components, then it becomes extremely useful. So I'm going to say Insert, Explode Line Sketch. I'll choose a line. I'm going to highlight the edge on the bottom of my nut so that I get a center point. And then again, I'm going to come up here. I'll highlight the edge of the bottom of my bolt, and I'll go right over to the center and click. Now you may be worried that you've just destroyed your assembly. This is not the case. If you come over to the Assembly Manager window, we'll click on Configuration Manager. And if I expand the default configuration, you'll see this explode view. If I right-click and hit Collapse, this goes right back to the normal assembly configuration. If I want to see my exploded view again, I just right-click, hit Explode. Okay, the next thing I want to do is I want to save this view orientation because I like this. This is very descriptive and it's going to be easy for the assembler to understand. The way to save this as a named view is I can click on View, Modify, and Orientation. And if I come right up here to New View, I can add a new view. And I'm going to name it Exploded Isometric. Say OK. I'm going to save my changes. And I will collapse my part. Okay, so let's make a drawing for it. I'll make drawing from assembly. I have not yet created an assembly drawing template, but we're going to use the piece part drawing template. It's not going to have enough pages, but it will be a good example to show you how to add pages and add drawing formats. So I'm going to deliberately choose piece part drawing template. I'll say OK. My views come in, and they're not really the best, so I think I'm going to make some changes. I'm going to get rid of the isometric. I'm going to get rid of this view. Now, what I want to stress to you about the first page of any assembly drawing is this is where we're going to tell the assembler where to set positions. Anything that needs to be located should be described on page 1. So what do we actually set in this? Well, the only thing we're going to set is how far up the bolt this nut is. So I'm going to insert a smart dimension. I'll go from that edge to the bottom of the head and say 2.0. So now the assembler knows how far up the shaft of the bolt they want to screw this nut. Okay, I also encourage you to put the overall dimensions, maximum length, width, and height. Oops. So when I put the maximum height on, in this case, I'm describing the height of the bolt. Well, that's already described in the bolt's piece part drawing. So as I've told you, you should only ever state a dimension one time, and that even goes across blueprints. So in this case, I'm going to make this for informational purposes only, or reference. So I'll come over to dimension text, and I'll put it in parentheses. I'll do the same thing with the head of the bolt. Again, this is controlled in the bolts drawing. We are not controlling it at the assembly level. And the maximum width. We do not put materials on assembly drawings. So for example, we could have a steel bolt and a brass nut, or we might not even know the materials. We might have a simple purchase part. So do not worry about putting a material note up here. I do need to have my isometric. I'm going to say insert, drawing view, projected. I'll project my view up. Isometrics always have the hidden lines turned off. We will need to make some changes to our title block. So let's do the first of the changes now. Make sure your name is in the drawn by category. The date, today is 10/26, actually 19, that's convenient. This comes in out of the properties from the assembly. We're going to say sheet 1 of 3. We're going to add a drawing. And we're going to double check our scale. Our scale is in fact 1:1. So I will make this 1:1. There. And that looks good. That's a perfectly acceptable page 1. Notice we have not put anything under the revision block. We keep this area clear of graphics at all times, so that as we put in revision notes, we can come down without moving any of the views. Okay, so let's go on to sheet 2. Oops. I'll approve that change, and sheet 2. On sheet 2, we're going to put that exploded view that we created. So I'm going to say insert, drawing view, model. We'll choose our nut and bolt assembly. Now, make sure you choose show in exploded state. And we're going to choose exploded isometric. And that brought in the exploded isometric view that we created and named at the assembly level. At this point, we're going to put identification balloons on it. And the identification balloons are going to relate back to something called our bill of materials. Our bill of materials is the list of all the part numbers that make up our assembly. To find the balloons, you can simply click on the Annotation tab and come over to Balloon. If you click on any edge, you will notice that a number automatically appears. This is being pulled out of the model and what will become our bill of materials. I'll say OK. Now we're going to add another sheet. So I'm going to add a sheet. It says the format could not be located, but that's fine because we have the format in our templates folder. I'm going to browse over to my templates folder. I'll say SolidWorks Templates 2019 and always choose Sheet 2 for anything after the first page. I'm going to say Open and OK. There we go. On Sheet 3, I encourage you, well, you will put in the bill of materials. To put the bill of materials in, we're going to say Insert, Tables, and Bill of Materials. The bill of materials needs a drawing to get its information from, or excuse me, it needs a view to get its information from. We're going to go back to Sheet 2, and we're going to use that special exploded view that we made. Make sure you use the class bill of materials template, the MEE 120 BOM template. Make sure it says top level only. Start at 1, and that should be fine. We're going to say OK. Our bill of material automatically appears. Okay, but we're not going to put it on this page. I want you to put it on page 3. And then just click to drop it. So let's take a look at what's on this bill of materials. The item number right here. This corresponds to the balloons that were put in to Sheet 2. So for example, Balloon 2 points at the nut, and if I look at Sheet 3, I see Item 2 corresponds to the nut. All of this is being pulled from the properties of the components. Okay. So this description, for example, screw 3/8/16 2.5 zinc plated, this is coming from the description of the model, and it's also the drawing title of the bolt. Same thing with a nut. My company part number goes right here. So my company will call this part 0004 and 0005. However, I'm buying it from McMaster-Carr, and McMaster-Carr lists it at these part numbers. So when I give this blueprint to a purchasing agent, they know to go to McMaster-Carr and order these part numbers in order to make my assembly. Very, very important, folks. Okay, so let's clean up our title blocks. So I'm going to go back to Sheet 1. My scales are good. Sheet 1 of 3 is fine. The rev looks good. Okay, that one's okay. Sheet 2. I have the abbreviated title block because I don't want to restate any of my tolerance information. I'm going to click on the view. The view is a 1:1 scale. So I'm going to come down. I'll change the scale to 1:1. The sheet should be 2 of 3. So So we're on sheet 2 and there are 3 sheets total. And lastly, we'll go to sheet 3. The scale is irrelevant. So I put in NA for not applicable. And then this entry becomes 3 of 3. That way the reader knows they have all the drawings that go with that package. I'll say OK. Fit it. And I will save my drawing. And that's it. So let's review what's on this assembly drawing package. Sheet 1. We're going to locate any parts who need their position set. That's why we have the 2.0. We're going to give the overall dimensions as reference. Maximum length, width, and height. Sheet 2. We're going to show an exploded view with balloons. This identifies the part number of each component and where the component is going to get installed. Lastly, sheet 3. I want to see a bill of materials using the course custom bill of materials template. These item numbers correspond back to the balloons. These part numbers are assigned by my company. We have the total quantities necessary for the assembly we're creating. The descriptions come from the models. These also match the title blocks of the piece part drawings. And lastly, the vendor and vendor part number of where to go buy the parts if it's something that is purchased. And that is how you do an assembly drawing, folks. Thank you for watching.